Well, good day, everyone, and welcome to another offering from our Construx webinar series. I am your host, Mark Griffin, the host of the Construx Inspect and Adapt podcast, doing double duty here. I am excited to introduce today's webinar being offered by Construx Senior Fellow Earl Beede. Earl is a longtime member of the staff here at Construx, having worked in the software engineering arena for many years. He's a prolific content creator, instructor, and consultant with us, and we are delighted to have him share his latest offering. Logistics points to make here. Initially, please feel free to ask questions in the chat or the Q&A section of your team's environment, and we will address them as we can. Earl indicates that he will have some time at the end as well. So what are we going to talk about today, Earl?
Well, hi, Mark. We're going to talk about estimating the unknown. But one thing we don't have to estimate, we might want to remind people about, is that 20 minutes past the hour here in the United States, we're going to have an emergency alert. How convenient is that?
Absolutely.
So I'm gonna try to say my most important point at 20 minutes past the hour, so that everyone's bleeping phones, alarming radios, and blaring TVs will all go, "What did he say?"
Exactly. So realistically, what we're going to talk about here is how do you estimate something you've never done before? So that's a good example of something we've never done before, is have a blaring alarm in the middle of your environment. So, but we get that asked a lot, right? A lot of clients ask that, and I'm sure you do in your team's environments. It seems like any really important project should be doing something that you've never done before, right? Something really interesting. And I bet that the usual and best answer that a lot of our clients usually say is probably, we have no idea. We've never done anything like this before.
It's the most honest. Yeah, it's the most honest answer, isn't it? Right? It's like, we've never done that before. How can we possibly estimate it? Yet they're being challenged by their leadership, particularly in a stage gate model, which we see very commonly, to have some sort of number. And so we've got to figure a way to deal with this unknown.
Yeah, I mean, unfortunately, saying I have no idea, I can't do this, is not going to help your organization do any basic planning, like things like, which of these projects should we go after, or how do you even fund the projects once you decide to do one? So today, I think you're going to try and walk us through that tightrope between like no information, we don't know, and wrong information, right? Because really you don't want an estimate that really isn't true. You want something that really rings true with what you're trying to look at. And the goal, again, as you mentioned, is you want to help these leaders and planners and even the team members make the best decisions possible given this unknown. And give some insight on how make this unknown less unknown, right? Bound the uncertainty. How do you plan through the unknown, making sure you get something out of it that actually is going to work for you and move forward. So that's enough babbling from me, sir.
All right.
Take it away.
Well, thank you, Mark. And I appreciate that great intro, because we're going to try to struggle with this idea of the unknown. So this is the series I call Thinking Aloud with Earl. And so what am I going to be thinking about today? How do we deal with this unknown? Well, I'm going to start out with this sort of what I think of as a continuum of knowing. What do we mean by when we say something's unknown? I think there's actually several variations of that. And then we'll talk about knowing that variation. How do we know the variation or the uncertainty that we're facing? We'll talk about that. And one way we're going to still deal with this is to try to buy information. We're going to actually spend some money to try to turn unknown into known. And then there's this last little part here, is that we will never know. It's truly unknown. And so how do we express that and share that with the team? So those are the things I'll be thinking about today as we try to estimate the unknown. A couple little tech tips today for those joining us. You can submit questions at any time in the Q&A. Mark will be monitoring the questions, so if he can answer right away, he will. He also will then queue up questions I will save some time at the end. If you're not seeing the full image, I am all of me and always that little Construx way down in that corner. This is a Teams thing, and so if you try to do fit to frame, I try to do the spotlight, you should get the full image. There is some feedback here, so if you'd like to do that, you're open to do that. And we are recording this talk. I will hopefully have it up onto YouTube in the next couple of days. All right, so let's go ahead and get into it. And we'll first talk about the continuum of knowing, or as I'm kind of thinking about a little bit, how do I think about not knowing anything? Which sounds like a pretty easy thing for me to do. I can think about not knowing stuff all day. But this is what I want to start thinking about. Is like, what do we mean when we say that something is unknown? This is, for those of a certain age might remember our Secretary of Defense, Donald Rumsfeld, when he gave his famous known and unknown speech, talking about this very problem where there's these combinations of known and known and known and unknowns. Practically and technically correct, but kind of confusing and kind of useless. But what we're focused on sometimes is the bottom row, right? Well, the three rows, right? When we have this known things that we know we don't know, there are things that we know, we just don't know that we know them yet. And there's truly things that we don't know and we'll never know. And that's kind of the kind of issue that we're facing sometimes is what category are we really in? So I think it's easier rather than trying to go with these four categories, which are often used by people to talk about not knowing. I like to think about a continuum of unknowing. A continuum of knowing. So if you see my continuum here, I think at the top of the unknown are things that where you're just don't know. We'll use phrases like I'm completely in the dark. I haven't got a clue, right? I have no idea what's going on here. Or you might more relate to your drunk uncle on a festive thing because they're talking about things that they have no clue what they're really talking about, right? They're just not understood or have any idea what they're speaking about. So there's this one end where we really truly don't know. And of course, at the other end of the spectrum, it's clear as day, right? That's just sharp. Everyone understands it. You know it like the back of your hand. It's very clear, very understandable. And as we used to say, that's a fact, Jack. That's truly known, fact, clear, understood. So what does this have this impact on our world of estimation? Well, if we think about estimating things, obviously down here near the bottom of my continuum, we can use very simple estimation techniques. These are things that we kind of do day in and day out. It's 5 miles from here. I'm doing 60 miles an hour. I can say it's going to take me about 5 minutes. It's very simple. If we get in an automobile accident and we go into a repair shop, they've done this lots of times. They have lots of data. It's all known stuff. They can just go bada boom, bada bing. And next thing you know, you've got an estimate for the repair. Now, if they find something they didn't know, they'll call you up and go, wow, we had a surprise. But generally, they know, right? They've done enough time. We can use very simple estimation techniques. This isn't our problem. Up in this range, though, we face some more unknown things. We have more uncertainty, less knowledge. And here's where formal estimation techniques. By formal, I mean techniques that have a way to express uncertainty and variation. These techniques will take things about inherent uncertainty and risk and combine that with the work itself to come up with ranges and stuff like that. But these what we might think as more formal estimation techniques, that you're following a procedure, that you're using things that have been recognized as a good estimation technique before, and works out pretty well. So we're going to see that range. Now, at the very top of my scale, let's be honest. When you don't know, right? When you're in the dark, you haven't got a clue, there really is no estimation technique. There is no technique, nothing we've come up with that says take something that's totally unknowable and then estimate it. You can't do it. But what we can do is try to do something to sort of drive that down into one of our other zones. We need to move it down the continuum. We need to take it out of the I have no clue zone into some other part of this thing. And that's what we're going to be talking about when we think about estimating the unknown, is how do we move some of that stuff down into a realm where we can maybe potentially use formal techniques or make it something even simple. How can we drive it down? And there's two basic strategies here. One is to separate what you actually know from what you don't know. Because sometimes, particularly when we're facing a large project, there's one or two things that are truly unknown, but there's lots of things that we already know. If I'm in that automobile accident again, we can see some damage. We know that. It's just the damage we can't see yet. And so we can separate out the two. We can say, well, this damage we know will cost this much. It's the stuff we don't know. But separating that out can make the problem a little bit simpler. Though we do have to be a little careful here, because sometimes when we say we know something, do we really know it? Right? Watching out for what we know that just isn't so. And that happens a couple different ways. One, the way I see it happen on our clients quite a bit is that they'll go and they'll say, oh, we have this big, scary project. Let's get together and spend weeks and weeks of planning time, right? We're going to figure out what everyone's going to be doing, what everyone's going to be building at the beginning. When really, we don't know that. We're guessing that. We're taking our best guess. We're trying to be honest and upfront about it, but we really don't know that yet. So we always want to base estimates on things that we know, not things that we're guessing at, not things that we're speculating at, but things that we actually know. So if we can find things that we know, then we can drive that down and then focus our techniques, our second technique primarily on the things that we don't know. And that second technique is to do something different. Instead of saying, hey, we don't know this, what we're going to do is create experiments that we know. Now, what does that mean? Well, that means that we're going to trade off this idea of, I don't know what's underneath with, I'm willing to spend 10 minutes, an hour, $50, something to look underneath there and get a better idea. I'm going to invest something known, that amount of money, to help expose that unknown into something more real. So that's what we're going to look at, is these two basic strategies, how to separate the known from the unknown and create known experiments. So let's take a look at that first one. How do we talk about things that we know but don't know totally yet? And the trick here is we're going to separate the idea of accuracy. Do I have the correct answer, from precision? How well is that answer to the actual point in reality? Because that's something that we get confused about all the time. We think something is true when it sounds very precise, when often in the world of estimating, when I hear a very precise answer, I'm pretty comfortable that it's not true, that it's inaccurate. It's very precise and wrong. So let's take a look at this. So one of the issues that I see a lot with our clients is that they have this big project and they're looking at all the parts and they say, well, we can't possibly estimate this. But you know what? We often know something about the pieces of this, even though we don't know anything about the whole picture. We can't understand the whole picture yet, but we often can say, you know what? This part I can kind of get a good sense of. This other part I can kind of get a good sense of. And then we can start trying to bound that a little bit. And what do I mean by bounding that? Bounding that says, you know, I think it's at least this. It could be as much as kind of thing. It's like where the edges of this thing kind of live at. For example, if I think about these pieces, right? If I think about the different pieces, I can ask some relatively good questions. How many pieces do I think there's going to be? Can I have a range or boundary on that? Is there going to be at least this many? And could be as many as that many. And that's something I could be pretty comfortable knowing. If I'm going to the automobile repair, I can be pretty comfortable that it's not going to cost more than the worth of the car, because at that point, they're going to total it. I have a bound on that. What kind of shape and sizes of my pieces? What different kinds of work am I looking at? Am I looking at big chunks of work, small chunks of work? Works in one area, works in some other area. I can probably get a sense of that too with pretty good knowledge if it's willing to be bound by something again. That I'm not trying to get the exact number. I'm trying to find what my bounds are that I'm comfortable saying. I'm pretty comfortable knowing that. How will the pieces come together? Might be something I can talk about knowing as well. We already have some techniques and procedures that we've used to do something like this before. Maybe we can do it again. So how the pieces come together might be another way that I bound it. And I can even start thinking about, wow, we have a pretty good tradition of rework. What will be the ones that are kind of suspect, that my knowledge is less good, my bounds are quite wide, and so maybe there's going to be a good chance for rework here. Maybe we can start understanding that and start putting bounds around that as well. So all these kinds of things are things that I can kind of know, even though the actual true value is unknown. And I think these are questions that I can answer reasonably. Now, that's kind of a weasel word here, that reasonably. What do I mean by reasonably? Well, reasonably says, have I found the right balance between my accuracy, having the correct answer, and the precision? Let's look at an example of that. So here are three different sort of estimates of the city, a city's temperature on Earth, right? This sort of normal range. Well, I've got one between minus 1,000 and plus 1,000 degrees Celsius. 30 to 50 degrees Celsius, minus 30 to plus 50 degrees Celsius, and minus 1 degree C to plus 10 degrees C's, 10 degrees Celsius. Well, I will tell you that this first one, right, it's accurate. The correct answer's in there, right? Because we're going from some totally morbid cold planet to the temperature of the sun or something. Yeah, Earth's city temperature is probably going to be in that range. It's accurate. It's true. However, I find that boundary somewhat imprecise, too imprecise for my knowledge. So this is not a reasonable estimate. This is, or a reasonable boundary or reasonable knowledge. I think it's unreasonable because it's too wide. We can do better than that. Over here, we've radically increased the precision. It's very precise, only 11 degree difference Celsius. That's pretty tight range for any city on the Earth. However, because it's too tight, it's actually wrong. Now, this is kind of scary because we often, again, confuse precision with accuracy. When we hear high precision, we think that it's accurate, and we start treating it as it's accurate to make decisions. But it's not. It is inaccurate. And so this is where we get in trouble with estimation all the time, is that we come up with estimates that are way too precise given what we actually know. And so something like this 30 to 50 degrees C, is something I think is reasonable, right? When I say the word reasonable, this is what I'm kind of referring to. It's reasonable because it's accurate. The right answer is in there, and it has a level of precision that is appropriate for what we really know at this point. I actually did research this a little bit, and yep, that's accurate, and it has reasonable precision. It's a little bit wider than it probably needs to be, but given what I think I know, I'm pretty happy with that. So when we start looking at all these questions again, all these questions we have here, and we say, can we get a reasonable answer? I think we can. And that way we're taking it from unknown, I don't know the true value, and I still don't, but I can come up with a reasonable answer that says, can I bound that value with something I do know? So let's see how this might work in practice a little bit. Let's say that I'm going from my house to the store, I'm going to drive there, and I know the route, and most of the route, it's a new store I haven't been to before, so I kind of know the route here. And I know that close to my house, there are some lights that I'm going to hit. But as I get further along there, I know there's going to be some lights, but I'm not quite sure how many lights there are going to be. And then we're just simplify this by the light problem, right? So how long will it take me to get to my destination, knowing that I have 4 lights up front and some number of lights after that? Well, again, we can talk about separating the known from the unknown. At the front, I know these lights, right? But what I don't know is their state. Are they going to be green to go or red to stop? I don't know. How long have they been red? If I show up and they're red, will they turn green soon? I don't know. It sounds like the 20 minutes is a couple minutes early. I'm starting to hear the alarms. So I don't know their state. One of the things I can do, though, is I can start saying, okay, and then the further lights, I don't know these lights, and I don't know their state. So I don't know the number of these lights, and I don't know their state as well. I'm not quite sure what they are. So up here in the front, I know if I show up and they're red, on the average, it's going to take me about 2 minutes delay, right? So I've got that down, so I know there's 4 lights, and on the average, if they are red, it will add about 2 minutes to my trip. Down here, I'm unsure of the number as well, but I'm going to assume, and this is where something is going. I'm pretty comfortable saying they'll probably follow the 2-minute rule roughly as well, that I could use that as a go-forward point right now. So here's we're going to talk about the importance of assumptions. I'm making an assumption here that I'm going to be clear about, saying, I know that these on top follow about a 2-minute rule, so I'm assuming these do as well. So how long is my trip? Well, if the first section of my trip, if everything's green, if I just cruise right through it, it's going to take me about 10 minutes. If they're all red, that is, I got 2, 4, 6, 8 additional minutes, it's going to take me 18 minutes at the tops. So my estimate is between 10 and 18 minutes. I've bounded it. It's going to take me about that long to get through the first section of my path. Down here, again, I think it's about the same distance. So if they're all green, it's about 10 minutes. However, I don't know the number of lights. And I think, and I'm going to make an assumption here, budget, I'm going to bound it with thing I know. It seems reasonable in that same distance is between 3 to 5 lights. I'll have maybe one less, maybe one more, maybe the same, but somewhere like that. And again, if they follow the 2-minute rule, this is going to be between 16 and 20 minutes. So my estimate for the second portion is between 10 and 20 minutes. So if you ask me for my estimate for the entire drive, I have to say between 20 and 38 minutes, something like that. Right? I've bounded my knowledge and I've been clear about where I've had to make assumptions, and I'm clear about what my bounds are that still have a sense of reasonableness with them. This idea of amount of bound and unreasonableness is often expressed on software development projects in a thing we call the cone of uncertainty. The cone of uncertainty is basically the limits of your knowledge, the limits of knowledge based upon your process. My drive here is a process. I'm getting from point A to point B. And as I drive it, I will discover whether some lights are red, some lights are green, and everything's going as I expected. And so what the cone here is showing is saying, early on in my cone, I have a particularly wide range of possible outcomes. Now, this is an idealized cone. Everyone's cone is a little bit different. And usually we're either on time or late, never just quite as symmetrical as this. But what we see is that early in the cone, early in the process of the drive, I have to have that wider range between 20 and 38 minutes. But as I'm making the drive, I'll start discovering which lights are red, which lights are green, and how many lights are actually in there. And so I will be able to quickly lower that imprecision as I actually do the work. And that's the thing with a cone, is that we do the work, we'll lower the uncertainty because we'll learn stuff. And so by the time we get into this relatively well, 25, 30%, we will find a level of precision that is more acceptable to a lot of stakeholders. Back here, what we'll have to do usually is talk about two different points, a not to exceed point and our planning point. A planning point here has got to be careful because we always want to talk about what we know, and that know includes a certain range of uncertainty, that uncertainty range that we'll have to add to it. And so when someone says, can we make a decision on this? I really like to have a single number. We'll say, sure, but understand that it could be as much as, but we're planning and aiming for X. And we'll talk more about that in a second. So that's one strategy. How do we separate the known from the unknown and bound that unknown so that we still make good decisions as a business? The second strategy we sort of talked about as estimating the unknown is to change those unknown into known things. That is, we're going to buy information. We're doing something that we know to try to make unknowns less unknown. That I'm going to do an experiment, I'm going to try something out, I'm going to do a spike, I'm going to do some kind of information gathering, and I'm willing to spend a certain amount of time to do that. And it takes this basic idea that instead of estimating this, I'm going to declare it. I'm just going to say we are going to spend a certain amount of time or resources to learn about this thing that we don't know. For example, going back to my automobile mechanic, I suggested one way we could do that was to say, hey, I'm willing to spend an hour of your diagnostic time to go explore this to see if there's much more damage. After that hour, then we can decide what we want to do based upon what we've learned. We've taken a massive unknown, turned it into a known, 1 hour of this diagnostic time to help us understand the bigger problem. Then if we did understand it, we could then say, oh, we now know it, we can estimate it. Or, hey, we didn't learn anything. I can then say, do I want to do another experiment or not, knowing that the first one didn't uncover what we wanted to do. And I can make this decision over and over again. This is particularly important if you're thinking about stage gate models. A lot of us live with stage gate models. These are gates that people put up to make decisions. Now, I want to be clear here. Stage gate models are decision gates. Decision gates are places where we make decisions about whether we want to fund more or not. And so these are really great ways to start thinking about buying information. because their goal is to say, given my understanding of the project, is it worth funding more of this? And usually we have 3 or 4 of these things before we get into a major development cycle anyhow. So we get lots of time to sort of buy information. And I want to separate these out in some people's minds from toll gates. Toll gates are slightly different. Toll gates are a tool used by quality people to say, is this good enough to go forward? Whereas the decision gates is about, given what I know, should I fund more? Toll gates are about, are you good enough to declare this actually done and satisfactory? So we'll use toll gates as a way to say, do we release software? We'll use toll gates to say, is this design good enough? Those are reasonable places, but for a stage gate model, these are probably designed to be decision gates. And as decision gates, we want to decide, do we want to fund the next thing? So estimation, particularly at these early gates up here, estimation is really about, should we fund the next bit? And what we'll see is that those early gates, what we want to do is fund a bunch of small investments. Am I willing to go from G1 to G2? Am I willing to go from G2 to G3? That's the decision we should be making here. And so our estimates need to support that. And bounded uncertainty is a reasonable way to do those kind of decisions. It's looking like about this. It could be as much as, but we can try to control it, and we'll come back after another small investment to help you understand the big decision. Once we get past usually some sort of initial development, then we're going to see that we want an estimate that has a relatively small range of uncertainty, that we're mostly known at this point because we did all these small investments, and that we know that then we can make an estimate that we can try to hold ourselves accountable to. That is, we can sort of make a promise somewhere after the launch of a development type of gate. And so what we want to start seeing is, how can we spend time in this area up here between our initial idealization and feasibility and even a little bit of development, right? Making and buying information so that we can make a commitment far enough in advance that the rest of the business can do the work that they need to do. But also give them enough information at G1, G2, and even at the beginning of G3 so they make the decision, is it worth funding this next bit, right? So the overall pattern here is that if we're trying to estimate the unknown, is to say we're going to switch that to these small investments. And as we make these small investments, we keep coming back to this saying, here's what we've learned. Here's what we want to invest in next. Is it worth it? That's the whole role of decision gates. And those decision gates can allow us to be able to move through that unknown area into the known area where we can make a more meaningful estimate. Because one of the things I hate is sitting out there at G1 or even G2 and someone says, oh, we think this is going to be a year, and we really don't know. But a year sounds like a big time, and so we say a year, and the business starts saying, great, a year, and they start making plans on a year. And a year later, we have to slide it another 6 months, 8 months, a year. We've been at Construx often called into projects that are in their 4th year of a 1-year project, because they try to make a bunch of decisions or on estimates that were not based on any kind of accuracy, but they were probably relatively precise. I just spent some time with a client working on their estimation procedure, and they were talking about 4 years out, 5 years out, trying to tell what quarter they're going to be delivering in. And it's like, they don't know. They can't know. And they've been having a horrible time actually being as accurate as they want on those initial estimates. And so we've changed their procedure to say we're going to be buying information early and waiting until we actually know to make a meaningful commitment. So how much should you spend on these things? How much should they cost? Now, Steve Taki, my coworker Steve Taki, has an excellent reference in his book, Return on Software. I think it's chapter 15 to talk about how to do this, but I'm going to give you a simplified version of this so that you could probably use this to say, okay, how much we spend on buying information? Because there's 2 main inputs. One main input is, if we knew the answer to this, what would it be worth to us, right? How much time would we save? How much rework would we cut down? How much profit could we generate if we actually knew this? This is something I think that we can use in reasonable estimation technique to figure that out. I like to use maybe a 5-point scale. I like to use 5-point scales a lot because I'm trying to avoid precision, because the 5-point scale is only 5 buckets. So I like to use a 5-point scale. And I can say, is this like a 3 worth or a 5 worth? 5 being the highest. And I can start saying, okay, 5 means we can save, X amount of money, a range of money, and we're good to go. And so I think this is something that we can reasonably estimate. What's the knowledge worth? The other thing we can also estimate is, given the experiment we're envisioning, what's the likelihood of actually learning about it? For my car example, if we say if we're going to take out and drop the quarter panel and look beneath it, there's probably a pretty good chance of learning, right? So that's a high probability. And again, I can use a 5-point scale here because, again, I think this is also very reasonable to estimate as well. So I can estimate the probability of this. And I can use, again, a 5-point scale. And I can assign actual numerical values to it. There's lots of techniques here I can use to help assign a value to the knowledge, what the knowledge is worth, and our probability. And what I can do then is I can then take the probability, multiply it by the worth, or if I have a lookup table, use a lookup table, and I can come up with what I think is my upper limit. Now, I said Steve Talkie has a slightly better formula for this. It's more involved, but certainly you would not want to spend more than this because the answer is not worth it. If you got a high probability and it's a high worth, you should spend a lot. Low probability, low worth, don't spend too much, right? Because we certainly don't want to spend time trying to buy information that we spent more on than the information actually is worth if we ever actually delivered it. So probability times worth is a reasonable way to start doing that. And then finally, if you start thinking about where this sort of matches up on our cone, if you're trying to imagine in your head, this is roughly-ish where we would like to sort of see it going. That is by the time we get into development, and then we're getting really into development, our second or third sprint, our second or third mini milestones if we're doing more of a waterfall. That's the point where we make a meaningful commitment because we have reasonably good knowledge. Before that, right, we have to bound it somehow because there is a natural limit on what we can actually know, be able to move forward. So those are our 2 strategies, talking about separating the known from the unknown and buying information. But what it comes down to, though, is that we have to be able to have this conversation with our stakeholders and be able to express this unknown. That is, how do we let them understand that there is a limit to what we actually know now? And that pretending to know, that we pretend to know, like, well, yeah, of course, this is exactly what it's going to cost, when we don't know, actually misleads them, right? So them knowing what we don't know is also critical information. They need to understand what our limits really are. So how do we express that? Well, just to be clear here, I wanted to bring up this thing from the IEEE Code of Society Ethics. For a lot of us in the world of software development, we are somewhat governed by the IEEE as sort of our major ethics board. And you can see here, as I highlighted in this little text here from them, that you really need to say that you have a realistic quantitative estimates of cost, schedule, or personnel, or quality, or outcomes. You need to provide the uncertainty of that estimate. You need to talk about what you don't know as well as what you know, what your bounds are of what your knowledge can reasonably talk about at that time. Because if we give unwarranted precision, even in the face of lots of unknowns, if we're trying to pretend like we know because we want to look like we're smart, look like we're a contributor, we're actually doing some damage here. I think there's like 5 things that are really being impacted when we say we know something that we really don't know. One is that, of course, we're unlikely to be accurate. One of my cool signs that I use as a professional estimator when I go in somewhere is that if they give me a relatively precise answer with lots of obviously unknown things, one thing I'm pretty comfortable saying is that number's wrong. I've had this work well for me year after year. I was on a committee once on a building project, not even software, on a building project. And the planners came in and said, this is going to cost $1.2 million. And I knew there were tons of unknowns. And I said, this number is bogus. And they said, no, we've used all the extra software and spreadsheets that we've got. And like, I don't care what you used. There's too many unknowns. You've made too many guesses, too many assumptions, and given all the uncertainty, it is unlikely to be accurate. And I was right. It was practically 3x, turned out 3x what they said it was going to be. And then once we've got that numbers, people start making decisions on it. And we start getting plans, and those plans are not reality based. I was with one client recently, and they were doing this in spades. They kept saying, oh, we're going to be able to get this done in a year or less. And it turns out, no, they can't. But they kept telling people they could, so everyone was making plans. And when they had those plans and they tried to follow and track against those plans, they weren't tracking against reality. And so they spent so much time in meetings trying to figure out how the work is trying to match the plans where the plans had no basis in reality whatsoever. And that is a huge waste of time. And when I come back in these situations and people say, well, our next estimate is like, why should I believe you? Well, you haven't been right since the Nixon administration. Why should I believe you now? This is not going to happen. So businesses become very jaded. They hear the number, they start saying, no, I have no confidence in you. And it's not going to help out anyone, especially my future career prospects, if no one ever believes me when I say it's going to be X. And what we end up doing is making wishful thinking our strategy. Maybe we'll get lucky this time. Maybe everything will go right. Maybe. And wishful thinking is not a good strategy for software development. It doesn't help us. We want to do small investments. We even want to use a technique that uses small investments throughout the entire thing, a more agile technique or evolutionary technique. But the idea is, can we make a decision to go forward rather than just using wishful thinking? Can we learn and then make our next step based upon what we actually learned? And finally, I think if you're doing unwarranted precision and face lots unknown, you're basically lying to your stakeholders. It may be all for the right reasons, and maybe because you feel like you're forced in that situation because they said, we must have a number. But again, if you say, oh, they tell me they must have a number, so I give them a number that has unwarranted precision, I'm basically just saying, here's a number, I pulled it out of my right ear, enjoy it. And do not be surprised when they come back later on not believing you, counting on wishful thinking, because we've misled them and now they're going to be upset with us at some point. One of my favorite sayings, and when I teach estimation, is that when the estimate and the reality don't match up, when the target, what the business wants, and the reality don't match up, there will be pain. Your only choice is when to experience the pain. And I'm saying here, as we're trying to estimate the unknown, we need to experience that pain up front by saying, here is the bound of what we know, and here's how we're going to resolve those unknowns through a series of small investments or doing the work. And here's where we can come back and say, we have bound it tightly enough that we can make a meaningful commitment. And that just brings me to this point of assumptions. When you have assumptions in your estimate, one of my Earl rules is that any assumption must have at least an 80% chance or better of being true. That is, if I make an assumption that I got to believe, yeah, this is actually I have pretty good confidence this is going to be true this way, rather than saying I've made some assumptions just for the sake of making this estimate work. Because if I have a bunch of assumptions that I don't believe in, I might as well just say, magic happens, and here's your number that you've been hoping for. One of my favorites that I run into time and time again is that someone shows an estimate they've been working on, and I say, okay, what are your assumptions? And they list a couple, and I say, all right, well, first of all, you came out with a date here. Are you assuming that everyone who starts working on this will continue to work on this uninterrupted, unpulled back on other projects, uncalled out to other things? And they said, well, yeah. I said, how likely is that to be true? Well, no, not going to be true. So why are you basing your estimate on this kind of number? Well, I have to come up with a number, and this is what the planning tool generated. Well, no, that's not a number. That's not an estimate. You're not helping the business make a better decision. Our goal in any kind of estimation technique is not to magically come up with a perfect number. Our goal is to generate information as best we can so the business can make a decision. And we do not generate information by making a bunch of stuff up that has no chance of being true. So one of the rules I want you to follow when you're trying to go from estimating the unknown is any assumptions you make must have an 80% chance of being true. I thought my lights up ahead between 3 to 5 lights following the 2% rule. Well, I'm pretty confident that's probably a reasonable assumption to make. If I would have said, I don't think there's any lights because I need to be able to come up with a number that has high precision, then that probably wasn't true, because like, what? An equal stretch of road with no lights? That doesn't seem very reasonable. Okay. So how do we want to express it? How would you actually go and express it? Well, I think there's a few ways we might actually express it. One way is we might talk about our estimate as X and plus or minus. Some people do this. I'm not a big fan of this particular one, just because when I say our estimate is, say, 6 months plus 7 months minus 2 months, everyone just remembers the 6 months, right? We're being held accountable to the 6 months. And so not my favorite, but certainly a way that people have talked about presenting this to stakeholders in the past. You can try a range, estimate from Z to Y, right? It's going to be 3 months to 12 months. Well, okay. Again, I think a lot of people focus on the first number they hear, so it's, again, not a favorite of mine. And this is one, a lot of pushback where my clients will say they don't allow us to give ranges. We're not allowed to give, we have to give a number. And so here's the one I've come up with that I think is a reasonable way to talk about and bounding our knowledge of what we actually know from what we don't know and still give them actual information. And that is, I would like to present that. Here is our estimate. Our estimate is it's going to be at least 3 months. There's no way we're going to go faster 3 months. We don't think it's going to exceed 12 months, and our plan is 7 months. This is our plan, and this is what we're going to track to. Notice the slight variation in here, right? We have a minimum. So if you were hoping for something lower than the minimum, not going to happen under the current scoping and ideas that we have. Can't see it going any shorter than this. And this would be if everything was just hunky-dory, perfect pie in the sky, smallest scope, no one changed their mind, fantasy number. But hey, at least you understand there's no going below this. On the other end, it could be as long as what? We've seen our projects go as long as this. This is when everything goes wrong. We don't make decisions. We fumble around. But we don't think, even in that scenario, given our world, we're not going to exceed that number. But we have a plan. And this is the critical. It's not our commitment. It's our plan. Our plan is to track and record and try to deliver it in X. Then they get their number that they're needing to make their decisions, the plan number. Now, I'm going to be careful because I'm going to come back later on and say, here's why I'm willing to commit to our plan, because I'm not willing to do that early on. But I will point out where in my life cycle I'm willing to make a commitment to the plan. But initially, this range is going to be quite high, but they're still going to have a plan number that they can use to make decisions on whether to fund the next bid or not. And this gives them some knowledge, even when we don't know. They can have something they can use to move forward on. Right. So, given those two strategies and the way we want to present, how can we sort of wrap this up? Well, here's my 3 zones. In the bottom zone, it's execute and deliver and learn, right? We know this, we're going to execute it, we can update our data, we can start learning what it actually takes us. If there's some changes going on, so we get a little bit longer or a little bit faster, we can learn about that and use that to update our estimates in the range right above us. In the range right above us, we want to use some sort of new more formal techniques like a proxy technique where we say, oh, on the average, my lights are, on the average, a class takes me, on the average, one of these UI elements takes me, boom, I have 23 times the average, this is how long, right? So we can learn from that bottom part to update and calibrate our models better in the middle part. And we let everyone know, because it is a model, we have some uncertainty on this because we don't know yet, but we have bounds on our knowledge, and we can then track against a plan. That this plan is not the best case, it's not the worst case, but it's somewhere in the middle that says this is the plan that we think we have a reasonable chance of getting at. We're going to track against it, but we always want to stay within our bounds of the minimum and the max. And for the top zone, we're going to use the early part of the project primarily to buy information, to buy down risk. This is why you want to do the riskiest part of the project early on, because you want to spend time and energy buying down that uncertainty, that unknown stuff, and turn it into something known. It's either going to work or it's not. And based upon what we know, we can make a better decision going forward. All right, and with that, I'm willing to open up to questions that have shown up in the queue. So if you haven't written a question in the queue, please drop a question in the queue. And I invite Mark back. I see Mark's back. You can share with any questions. I also saw a hand show up. And I don't know how to do. Can the hand person write a question, or do they want to make a statement of some kind? Any clue on that, Mark?
Maybe they need to go to the restroom. Who knows?
That may be.
So here's a question from Gary. Gary writes, you're right that the management team always remembers the first number. Wouldn't it be better to list the worst case first, the probable realistic estimate, and finally the best case? Isn't that what Dancing with Bears advocates? I try to get management to read that book.
Yeah. So for those who don't know, Dom DeMarco and Tim Lister wrote a book called Waltzing with Bears. Wasn't it? I think it was Waltzing with Bears, actually.
Waltzing with Bears, yeah.
Yeah. And it's a book about risk management. And what they say was in presenting an estimate, I think it's in the book, but leading with the worst case, I certainly think that's reasonable. That's the first number. When I teach estimation, I say that's a good way to present it. I actually like to say, don't call it the worst case either, right? Call it your 90% confidence case, my 50% confidence case, and my 20% confidence case. Because you call it your 90% confidence case, that sounds like something people want. They don't want a 20% confidence case. They want a 90% confidence case. And I'm leading with the biggest confidence. And so leading it that way and presenting that way is even better in some ways. Though, you have to get them to understand it's like we're going to plan and track against a 50. And so that's why I kind of suggested this way of saying it's going to be at least, it's not going to exceed, and our plan is. Because what I think they really want is your plan. What is your plan that you're going to track and sort of benchmark and hold yourself against and try to adjust other things to try to help it meet? So that's how I see that working. But yeah, leading you with the worst case, not a bad idea. But I instead suggest you calling your 80% or your 90% confidence case.
Good answer. Here is another one. What might remove the unknowns look like? Often I might spike and get an idea what something will take, make an estimate on that, only to come back to the ticket several sprints later and it explodes in actual time compared to the estimate.
All right. So one of the things so let me just make sure I understand that, and which is my stall way to think about a good answer. You thought you did some buy information. You thought you understood it pretty well. And then when you actually go into work on it a little while later because you thought you understood it, it just really exploded. It's like, well, I wasn't even close. That happens sometimes. The question is it happening on a regular basis? If it happens once, life happens. We have to have some inherent uncertainty to deal with the fact that life happens. But if it happens regularly, I would start saying, okay, why is our buying information not working? What are we doing wrong in the buy information part that's not exposing that? That's one thing I'm going to worry about. The second thing, if I'm buying more information, is that I still might have some residual risk. Now, in formal estimation techniques, not only are we dealing with this bounding of the knowledge, which we talked about, but we'll want to add some potential risk. And if you're saying, we did a buy information, I think we understood it, but you know what? I have some uncomfortable feelings about this deal because your team probably either said, we nailed it, or it's like, well, we kind of got a better picture, but it's still a little fuzzy. You might want to identify a new risk. And then you could do the same thing what we did with the buying information. You could take the risk probability. How likely is it that it's going to blow up? How much would it blow up if it blew up on us? How would be the worst case? Then the probability times the severity. Add that much more into your bounds. Include that in your buffer, if you will. And then still go back and look at it saying, we tried to buy information and it failed. What went wrong that we can correct that in the future?
Yeah, I mean, you always advocate for that experiential phase where you adjust. You learn something from what you do if it was wrong, and then try and make a better shot at it in the future. So Mark asks, could you use the PERT weighted average for your plan rather than 50%?
Well, so now you're getting into the formal estimation techniques part, which I wasn't teaching estimation. I was just trying to say, how do we deal with unknowns? But once we get in the formal part, you're going to find that if you're doing individual expert judgment estimates, you got to figure out a way to fake out what you know as the probability distribution. And you want to do what's called a 3-point estimate. What's your worst case? What's your best case? What's your most likely case? Now, these numbers tend to be optimistic. And so the people at the Navy came up with a program evaluation review technique, or known as PERT. PERT just comes and says, hey, if you take those 3 points that came out of someone's gut and then do some math on them, you can get it closer to a true nominal estimate, which is what a professional estimator wants, which is a good thing to plan against. So that would be my plan. That's how I would come up with my plan number. When I said I presented, I said I have my least, it should not exceed. And my plan is I probably, if I was using individual expert judgment, did a PERT formula. If I was doing an analogy estimate, I was probably using an actual previous project plus some percentage difference. I think it's 10% bigger, 20% bigger to come up with my plan number. So I did some technique to come up with that plan number, but PERT could have been one of them.
Okay, Rogerio says, in order to provide a good uncertainty level about an estimate, you should have a good math or statistical knowledge. People are just not used to it.
You know, probability is screwed up. It just wants to drive you nuts. People who truly understand probability, I think, obviously have some other part of their lives that's really messed up, because that takes some serious brain power to do it. And the rest of their life is probably they stumble over carpets or something because they can't manage their feet, because so much brain power is understanding probability. Yeah, it's hard. Statistics and probability are not something that people get. There's a whole YouTube channel on a guy that just loves to talk about how people don't understand maths. Right. I just watched one the other day where he said Bloomberg spent on his Democratic nomination against Hillary Clinton $500 million. There's 357 million people in the U.S. He could have given everyone $1 million and still had cash in his pocket. And it's like, no, that's a subtraction problem. It's a division problem. He can give everyone $1.50 and with his 500 million. So
absolutely.
Yeah, it's so, yeah, people don't get math. And this is why I talked about this idea. It's not going to be as much as it's going to, it's at least, it's as much as our plan is. I think that's a language that most people can understand, right? I'm not asking them to do a 50% confidence or a 20% confidence. I'm saying it's not going to be any shorter than, it's not going to, we're highly confident it's not going to be any longer than, and our plan is, to me, that's just a language that people understand. And I don't have to go in and do the statistics and stuff with them. As an estimator, I better know that, right? The estimator should have some basic grasp of reasonable probabilities, reasonable statistics, but the people receiving it, I shouldn't have to require it of them. They're trying to make a decision. They can use my plan number to make a decision, but I'm also telling them to come back when I'm going to come back with a revised plan, because I will have learned more by then. Right? I'm going to sell the beginning as a set of learning points rather than commitment points.
So it's a good segue. Michael says, what about continuous rolling wave re-estimation as more information is known? That's kind of what you're talking about, really.
Yeah. Yeah. So I was at this client, we were setting up an estimation procedure for them. And we found that between when the idea first got brought up in someone's head until they were about a third in development, we're going to have 4 or 5 major estimation points where we're going to tell them we're refining your estimates and we're not willing to make a commitment until this point. Now, I think there's a point where you need to make a commitment, right? The business needs to know when this is going to come out, needs to understand what the scope is going to be, and starts making plans and budgets on really definitive numbers. But we also argue that that's probably not known until you're about 20% of the way into the actual development phase. Not all the feasibility analysis, not all the initiation discussion, but actual development before you start figuring out what is it we're really building here. I was just on several years ago, I was working on a large project, 50 million euro project. And one of the things they kept saying in those early pre-phases was, we're going to have no hardware changes. We're going to have no hardware changes on this medical device. Well, 10% of development, they decided to change a bunch of hardware. You have to get into the point where your rubber's truly meeting the road and people have to make hard decisions, not just think about what they might want before you really know. And so, yeah, we're going to do some rolling wave estimates, and we're all going to be estimating the next section. But after that commitment point, we're still going to estimate and still do those estimates. But now it's changing from, am I going to give you information to make brand new decisions, to really, how do I use the information I'm gaining to help me control the project to meet my commitments? So I'm sort of switching gears a little bit from, hey, let's figure out how big this is, to how do I control it to meet what we define that we're willing to spend for the kind of scope we're hoping for.
Okay, here's another one for you. I am interested in the power of design to control cost levels, but smart low-cost design, especially in an incremental way like IBM Mills Cleanroom or like Musk. Any ideas?
So, sure, ideas. So, when you're talking about design, you've got two or three things that are sort of interacting that you use to help make your smart designs. One is having good design knowledge and pattern knowledge and that kind of stuff so that you're following known things that people know how to build. There's no use building the most grand design that no one can figure out how to actually create. And so that's so. Do you have a good design pattern? The second thing that you want to do with design is that you want to have good requirements. If you don't know the problem you're trying to solve, your design is not going to be any good, regardless of what patterns you know, because you haven't built the right thing because you never understood the problem. And then the third thing is that to really get those requirements well, I would say that you need to have a series of test cases, scenarios that you're trying to say, my design has to be able to explain how it's going to solve for these scenarios. The city of Seattle did that years ago when they were doing some outsourcing, is that instead of writing a detailed requirements document in some ways, they said, here's all the scenarios that we need to support. Show me how your software does that. And the vendors would say, well, here's our canned demo. And they said, we don't want your canned demo. That doesn't do any good. Show us how you solve these particular problems. And that way you get, with the good pattern stuff, hopefully the most elegant design that actually solves the problems that people have, as opposed to all the features that they ask for or all the things it could do. What is it you're actually trying to do? So those are my thoughts on that, but that's probably on the answers free part.
All right, here's the promise of AI. Will AI eventually allow for more accurate estimates in the face of the unknown?
Well, that's an interesting question. And so we've seen a form of AI machine learning in our map software for a decade now, right? Not too bad. But you can still see that even on relatively short distances, they can be off by, it was a 15-minute trip, it came off by 2 or 3 minutes, which is a relatively large percent for AI. There's still uncertainty. Did I make that light? Was there someone at the light who forgot to go for a round? And all of a sudden, boom, 2 more minutes were added to my travel time. So we've had this. There's still uncertainty in there. It's going to help us bound it a little bit tighter, I think, but I don't think it's going to eliminate the uncertainty.
Well, that's good. I think you already answered this one. Here's one. What if leadership demands a specific number, not a range? What can we do? I think you touched on this, but maybe you just hit the Cliff's Notes version as an answer here.
Right. So I was just with a client and they were saying the exact same thing. They don't give us a number. And I say, this is where and this is how the conversation typically goes. It's like, well, we need a number. Well, I'm sorry, but it's going to be at least as much as here's our plan. No, you don't understand. We need a number. You need to give me a number. And you say, well, I understand you need a number. And here is the outcomes. And they might say something like, well, you're a smart person. Why don't you just tell us what you think is going to be? And I say, I'm a very smart person. That's why I'm telling you it's at least, it could be as much as in our plan is. This is the techniques we talk about in our estimation class about how to present and defend an estimate. And one of the tricks is to say yes and. You agree with whatever they say and you restate what you actually know. And while they say we have to have a number, you can say, well, you can use the plan number for planning purposes. I've given you a number. That's why I like this idea of a plan number. This is our plan number. You can use that for planning purposes. I'm going to come back in a month, in 2 months, in 6 months, whatever that period is in your development cycle, and give you another plan number. Right? It should be within the bounds we talked about before. I should never go outside the bounds we talked about. If I go outside the bounds, I'm a bad estimator. But if I stay within my bounds, even though the plan number may shift up, if I'm still underneath that top bounds, I've given you a pretty good estimate.
Good one. So here's a slightly longer one. And I would say that you've been focused on business value in a lot of your requirements training and consults at late, and particularly in some of the podcasts we've done. So I think this might be in your wheelhouse. It's along the lines of, what is knowledge worth and the pretending ideas that you shared today, but how would you coach the estimate provider and maybe pushing back at the requester, like pressing on the importance of the business value? Like, is the value so high we as an organization can afford a wider, more comfortable range, or like G1, G2 kind of planning? I mean, just this notion that this is so important to the business that you should give me some license to give you a wider number, right?
I think I'm not finding anything difficult with that. One of the things that I tell my estimators that you are the professional estimator. They're not the professional. They're the professional business person. As a professional business person, their job is try to squeeze as much value out of development as possible and to get as much value out of the product as possible. That is their goal in their life. And so they're going to ask you for lots of things that you cannot provide because they're supposed to ask you. That's their job. And your job is to provide correct information, not to roll over and play dead when they push back. Because as a negotiator, one of the things they teach you in negotiation school is that until you've heard no at least 3 times, there's something on the table. Right? And one of our things we do as developers a lot of times, they say, well, we've got to have it 3 months earlier. And we go, well, okay, we'll see what we can do. Well, they're thinking, obviously, there's fluff in there because they didn't say no. But you are the professional estimator. You made the estimate. You get to present it as you see fit, and you should be presenting it with bounding what you actually know with that inherent uncertainty.
All right, I got one more for you.
Okay.
Grab.
Yeah, we're running out of time here.
You have a really good swing at this piñata. Do you think agile methods are making estimates less important for a project? This is the old no estimate movement, right?
Well, one of the things I help people understand is Agile uses estimation differently than we do in traditional project management. I think going up to a business and saying, hey, give us $20 million to fund this area and we'll build something valuable to you isn't going to get funding. As long as funding stays on annual planning cycles for corporations and organizations think in terms of projects, then we're not going to get away with this estimation. Would it be wonderful if we thought about products and then just saying how much we want to invest in a product per year and then build the most valuable stuff? Sure, but I don't see organizations moving that way. So our traditional estimation is still going to be important for them to decide which projects in the portfolio they want to fund, what sequence they may want to fund them, what resources are needed to make them happen. I think that's still going to be going on for quite a bit. Too many matrix organizations out there, not enough just pure product organizations that are doing this, what Agile would want. And then Agile uses estimation differently. They're doing it as a secretive way to force collaborative discussions. They're not trying to predict the future or make a plan even. They're just trying to say, do we 2 people understand the same thing the same way?
Terrific. I think we're top of the hour. With that, I think we're going to bring this session to a close. Thank you so much, Earl, for your insights and your answers to the questions.
You're welcome.
And I'll mention to everyone that if you disconnect and then say, oh, crap, I should have asked Earl something, blah, 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 blah. Or if you want to have Earl comment on your own environment, feel free to send along your question or request to comments@construx.com. Earl would be happy to chat with you offline. And also a reminder, this webinar will be uploaded to our YouTube channel shortly. So all participants will be getting a link so they can share with colleagues and bosses to, up-educate as you see fit. So thanks to all of our guests who listened in today. And with that, have a great rest of your day.